Taking a break. What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are going to do a global contest, virtual contest of Codeforces Global Round 11. I know it's a different time to be live streaming here because normally I don't live stream at this time, but you know, I need to live stream every day. All right, and it's very difficult for me to live stream nowadays, but yeah, I'm gonna have to do this. So yeah, let's get into the global round of 11, and we're going to do these problems. So yeah, anyone in the chat, comment in the chat, anyone? So 5 minutes. So my plan basically is to try to solve at least 3 problems, 2 to 3 problems in every round, and then solve one. Okay, so if normally I could solve one and then barely solve the second one. So if I am able to solve 2 problems, I should be able to get to green. Ideally, I should be able to. So yes, yeah, that's what I'm going to do now. So let's do these problems. Let's just keep waiting a little bit until the round starts. So yeah, what time is it right now actually in other countries? Let's see, what time is it in India? It is 1 a.m. Oh, my fault, guys, my fault. 1 a.m. Okay, well, I mean, sorry guys if I'm live streaming way too early for you guys, but it is what it is. Hey, hi, Mohawk, is that how you pronounce it? I hope that's how you pronounce it. Hello there in the chat. Hello there. We are going to do a Codeforces Global Round 11. And I believe I did not solve any of these problems, or I haven't even seen any of these problems yet. So yeah, we'll try to solve these problems, and if we are able to, then we are able to. I don't know. Let's just see if we could solve these problems. I try not to make it. I tried to not look at the chat because the reason why is that sometimes people try to give hints, but yeah, I'll try to solve it myself for a few minutes, and then I'll look at the chat in case if I really can't solve it, I'm absolutely stuck at it. But yeah, my approach is to try to go through different variations of the problem. If it's greedy, I would do greedy. If it's divide and conquer, I try to divide and conquer. But yeah, that's what I do. I'm doing ideally. Yeah, and let's just keep going with these problems. Thank you. Oh yeah, thanks. Thank you so much. I'm glad I pronounced it correctly. Thank you so much. Oh wait, do you mind if I say your name during these live streams? These people in the chat. Thanks. I'm glad you learn a lot. I'm not really the best, most profound teacher, but I try my best, you know. You gotta try every time. Yeah, before the contest begins, we have 2 more minutes, and then we'll keep doing these problems. And then yeah, I did not actually do the ad coder contest today. I didn't wake up early enough. It's 7 or 6 a.m. where I live for the ad coder, and it actually finished. Yeah. Oh no, wait. No, it didn't. Oh, it's on Sunday. Did it get moved to Sunday? Oh, it's on Sunday. Oh, I thought it was on Saturday. That was weird. That's really weird. Okay. Well, it's on Sunday. Okay, well, I didn't miss it then. I'm glad I didn't miss it. It seems like I'm not having a smooth view from the YouTube is glitching out. It's glitching out. But yeah, I hope you guys could see. Oh, okay. Hope you guys could see my screen. We'll keep trying. I need to get to green. I used to be green on top code. I used to be green on Codeforces. Now I'm not. If I'm able to get to green, I would love it. Pretty much, yeah. So I realized the first problem is mostly a math question, and then you have to figure out the trick. The second problem is always a greedy question. So if you do a lot of greedy, you might be able to pass that. Third question is, it's mostly dynamic programming, but I'm not really good at dynamic programming though. But I'll keep trying. I'll just keep trying. Do more problems. The more problems you do, the better you get at them. The more likely you're to solve them. But yeah, let's see. Are there actually? Oh, thanks. You finally catch up my live stream. I have not been live streaming at all. Sorry, dude. I have not been live streaming at all. I need to live stream. So if I want to match with India's time, I have to live stream very early in the morning. So what is it? I would have to live stream at 9 a.m. Eastern to India. Let's see. What is that? Okay, yeah. So I would have to live stream probably at 8 or 9. So maybe I'll do that tomorrow. I don't know. Let's see. 8 or 9 is 6:30 p.m. I have no idea. Let's start. Avoiding 0. Okay. Given A, you want to create integers B. B is a rearrangement of A containing the same values. And each value appear the same number of times of the two arrays. In other words, a multiset A1 to AN are equal. Okay. For example, if 1, -1, it's the same thing. 1, -1, 1, 0, 0, none, and ranges in. For all K, not range. So now we want, for all K, 1 to N, the sum of the first K elements of B is non-zero. Formally, for 1 K equal 1 to N, it must hold that sum of the first K elements are non-zero. If the required properties do not exist. Okay. Let's see. So we have 1, -2, 3, -4. We want the sum of the first K to be non-zero. So that means that actually this doesn't even matter because -1 plus 3. Okay, so if the absolute value of the first one, okay, so 1 plus -2 is -1 plus 3 is -2 plus -4. It wouldn't matter. This doesn't even matter by itself. If they're all zeros, we're gonna print out no. Yes, if it's 1, 1, -2, 1, 1, 0, -1. Let's see. 1, -1. Okay, so that'll give you 0. You could try alternating. You could sort by. Let's see. So we could take the two sums that are 0 and then we put them at the ends. Let's see. -40, -13. What if I take 13 and move it to the front? Yeah, okay. So if we have two of the same absolute values, right? So if we add -40 with 40, we need to insert something between. So all that matters is that we need to insert something between. So if it's, let's see, -40, 13, 0. So this, like if 13 was gone, then it would be 0, 0. Then that's not good. So we need to get two sums that add up to 0. Let's see. One thing, we could sort it. Actually, that might just be it. You could just sort it. Because if you sort it, and the negative is going to be on the far left, and then the positive 40 would be on the right. So I don't think you could at all get all zeros. You could get the sum of any value to be 0. Wait, hold up. What if we have -4, -3, -2, -1? Okay, what if we have -3? Okay. -3, -2, -1, 0, 1, 2, 3. 1, 2, 3. So this would get you 0. No, it wouldn't. Last value would get you to 0 if they're symmetrical. I think it would 0, 0, 0. Yeah, so if it's symmetrical, it will get you to 0. Okay, yeah, so sort it. What if I put the 3, take the last value of the 3, put it over here? So what if I take the last value of 3, put it over here? So then we have the, oh no, not that. So I take the last value of the 3 and I put it over here. Then you would have 3, -2, 3, 2, 1, 0, 1, 2. Yeah, okay, so that would work. So what we could do is we could sort it, then we loop through from the beginning to the middle, right? And then we check, is the beginning, compare the beginning to the end, the absolute value of the current number to the end, to the corresponding end value, is it equal, are they the same? Because if they're the same, then that means we have to take the last value and insert it between. Yeah. So, yeah, I think that would work. So like, hold up, let me get my trusty thing. So if I have this, we need to, okay, so if I have, what is with my pen? What is with my pen today? Okay, so if I do, let's see, we have sketch. Okay, so if I had like, let's say I have 3, -3, -2, -1, 0, 1, 2. Actually, let's just close this again. Okay, -3, -2, -1, 0, 1, 2, 3. Right, so these, if you were to sum them up, you're going to get -5 plus -1, which gets you to -6. And then you add 1 plus 1, you get to -3 plus 2, right? You get -1. Wait a minute. Oh, no. -5 plus 2, -3. And then you add 3, you would get 0, right? So if you add up all the numbers, you would get 0. And that's not what you want. You don't want all the numbers to add up to 0. So what you do want is actually to have -3, 0, 1, 2, 3. You want to, so what I'm going to do is I'm going to go here, loop it to the middle. Check this with its corresponding end value. So this, is the absolute value the same? So if it's the same, I'm going to take this number, last value, and I'm going to swap it with the I plus 1 plus 2, right? So the reason why I'm going to swap it to the second one to the right from here to here is because that way I guarantee that the sum of the numbers are not going to be 0, right? If I put 3, like if I take -3 and I sum any value like b and then -3 and +3, you're guaranteed, like if you know this value is not 0, like if this value is not 0, you're guaranteed that this sum is not going to be 0, right? Because if this b value is like 5, you're gonna get -3 plus 5. That'll be 2. 2 plus 3 would be 5, right? So you're guaranteed that the total sum here is not going to be 0, as long as this middle value is not 0. Okay, so what we're going to do is we are going to loop through here to the middle. We need to check if this value is not 0. So if it is 0, then that's a problem. We need to find the next non-zero number and then swap it with this. Okay? And then we need to swap this number with the corresponding last number. So it will become 3, -2, 3, 0, 1, 2, negative 1. So then if you sum up the numbers from here to here and the end, 3 plus negative 2 would be 1, plus 3 would be 4, plus 0 is 4, plus 1 is 5, plus 2 is 7, plus 1, negative 1 is 6. So that's not going to have any problems there. So I think that's what they mean here. Yeah. For all 1 decay, the sum is not 0. Okay, so yeah, I think that's all you have to do. Yeah, so what we're going to do is we're going to sort it. So let's read in the array values, and then we're going to sort it. So we have t n vector a of n. We're going to go through and we're going to read in every number. Now what we're going to do is that we need to, what's the problem? Oh. Okay, now the problem is that we need to actually get the these numbers. We're going to sort them. Okay, so once we sorted them, we're going to loop to the middle, and we're going to check with the beginning with the end corresponding number. So we're going to loop to the middle. So we're going to do for int I equals 0, I is less than n over 2, I plus plus, and we are going to get the corresponding, if the current value, if the absolute value of the current value is equal to the absolute value of a at the last value, which is n minus I minus 1. Okay, then we need to swap. We need to find the first non-zero value. So here, negative 2. We need to get a non-zero value here, right? So to do that, we have to get, so we need to check if I plus 1 is a non-zero. So now we need to check if a at I plus 1, so the one on the right, so that this middle value, is this equal to 0? If it's equal to 0, we need to loop through from, go to the end, and we need to swap. We need to find the first zero value, and then we're going to swap it with first non-zero value. Swap it with a at j and I plus 1, and then we break. Okay, so yeah. Otherwise, we are going to swap the last value with the I plus 2. So we're going to swap the last value. Swap the last value. So yeah. So otherwise, so this is already equal to 0. So in this case, this negative 2 is this is already not equal to 0. So it's like 3 or 4, whatever. Negative 1, negative 2, 3, 4, whatever number it is, right? And yeah, we swap it with excuse me. And yeah, I think that's it. I think that's how you would do this problem. So if it's not equal to 0, we're going to swap. So that means that the middle is not equal to 0. We're going to swap the last value with the a at I plus 2. Okay, so now once we swap that, we're good. Okay, so we already swapped that. Would this work? At the end, we just print out. At the end, we need to actually check the prefix sum to see if they're all not equal to 0. So we have to loop through from beginning to end. Current sum current sum plus equal to data at I. If current sum is equal to 0, then we say no. Actually, possible equal to false. Possible. So original, let's say possible is true. Then we say possible equal to false. Then we break. If possible is true, see out yes. Otherwise, see out yes and then print out the array. See out yes, print out the array. Okay. And then after that, we just, I have no idea. Just print out no. Yeah. And that's it. There might be a few test cases where this fails, and I could actually think of a few ones. I don't know. This may or may not work. I'm not 100% sure this works. Yes. No. Oh, the second one's yes. Huh. Oh, put the positives all at one end. Oh. Oh. Okay. How about we not do it right now? Yes, no, yes. What if you put all the positives on one end and put all the negatives on the other? Actually, maybe that won't work. Because I already did that case. Put two positives, one negative. Then put a positive, negative, positive, negative, positive, negative. So to put two positives, one negative, and do positive, negative, positive, negative. I think that would work. Hold up. So I'll do that. So let's not do this. Okay, so let's not sort it actually. So we're not going to sort it. What we're going to do is we're going to take two arrays. This is going to be pos. This is going to be negative. If a at I is greater than 0, we're going to push it to pos.push a at I. Otherwise, pos.push neg.push neg.push a of I. Okay? And then after that, we are going to, yeah. We don't need to sort. We're going to alternate two pos, two negs. Okay? So vector result. Okay, so what we're gonna do is we're gonna do vector result dot push back two positives, so we're gonna do positive at 0. So we're gonna push two positives. And then we're going to push two negatives. Wait, hold up. positive, two positives, a negative, and then positive, negative, positive, negative. Okay, so positive. Wait, can I do this? Pos dot pop back. Can I do that? I can't do that. Okay. V. Let's just pos dot pop back. I can't do that either. Wait, get last value. Actually, get first value, a vector. C++, let's see. Front, get the front. Dot front. And we pop back. What is pop back removes from the front, right? Or is it move from the back? Oh, delete the last element. Okay, so then that means we have to push back the last element then. And we pop back the back. We do the same thing twice. Now we need to get the negative, get a negative element, and then we're going to alternate positive, negative, okay? Okay, so then now we're going to do the same thing here. This is going to be negative, the pop back. Now we're going to alternate positive, negative. So now we're going to do, so we already have 3 items. So we're going to start from 0, 1, 2, 0, go up to n minus 3, I plus. So we already have 3 items. So then now what we're going to do is we're going to do if I is equal to 0. We're going to pop back positive. So we're going to do pushback, result pushback positive. Else pushback negative. So that's going to alternate. And then after that, I think we're good. Let's actually print out the array so we're not crazy. Let's make this result. Actually, it should print out the array if it does work. If it doesn't work, I don't know. Am I lagging? Out of bounds. What am I out of bounds on? Back is on empty vector. Okay. So, you have to check if it's not empty. Okay. Now it should work. 1, -2, -3, 4. Why is it not working? Back was on empty vector. I said pause not empty. Back is on empty vector. We pop back. I don't know what is going on. Why is the back on empty? Oh, wait, hold up. Wait a minute. There's 2 pos, 2 negative. We push back, pause back. We pop back. What is our positive? Positive is now 1. What is our result? Result is 3. The result is 3, 1. Okay. Now what do we do? We push negative, -2. Why did it say it's not possible? Positive, +4. Oh! 3, 1, 3, 4. Oh boy. Okay. Okay. So that didn't work. Let's see. Let's think. Back to the whiteboard. Um, let's see. I don't want any of the values from the beginning to the end to equal 0, right? Summation up to the ith value is equal to 0, or up to the kth. But that doesn't stop me from doing it from the end, though. So is it true that if the suffix array is... I don't know. Actually, let me think. Let's keep thinking. What do you guys think? I can't even see the live stream anymore. Whoa. I'm lagging. Oh yeah, I do need to change my laptop battery. Thank you for telling me that. Where is my laptop battery? My laptop battery is right here. Okay. Not really. I don't think I have the best C++ videos. New Boston has better videos than I do. Let's see. There must be a way to solve this. Okay. Oh, okay. I think I got it. Okay. So let's say we have back to this example. -3, -2, -1, 0, 1, 2. Okay. 3. So let's say we have this. Sum up. So we sorted it and it looks like this. This is gonna get to 0. So what we're gonna do is we're going to last number swap with the second one. 3. So we have -3, -2, -1, 0, 1, 3, 2. Let's see what this sums up. Because you get to be -5, -6. -6 plus 1 plus 3 will give you -5 plus 3 would give you -2 plus 2 would give you 0. No, that's not right. Okay, to take one of the numbers here, 3, swap it with let me think. I only could think of through to here. Wait, so let's see. -3, -2, 3. -5 plus 3 gives you -2 plus 0 plus 1. Okay, so that definitely works. Yeah. Let's see. What is the problem? Let's go back to your original algorithm. What was the problem with the original one? Wait, hold up. I don't know why I did this. Crap. I can't redo. Rats. Okay. The middle is equal to 0. Oh, what if there's no 0? That's the problem. There's no 0. You cannot just take the... Oh, okay, I got one. Okay. Okay, so let's say we have -3, -2, 0, 1, 2, right? So -3, -2, 0, -1, 0, 1, 2, 3. So this is gonna add up all to 0. That's not what we want. So what we're gonna do is we are going to find a magnitude let's see. -3, -2, -1. Find a magnitude greater than -3. That's not possible. Then do a -2. Do +2, so -3, 2. Find a magnitude greater than oh wait, we could keep building up the sum. That's what we could do. So like, okay, so we could pick a number, -3, right? Plus -2, you get -5, right? Then if it's, okay, so we have this number, -3, -2, -1, 0, 1, 2, 3, right? -3. I cannot have another magnitude that is 3, right? So what I'm going to do is I'm going to find the number that is magnitude not equal to -3. So then I'm going to add it. Okay, so then I have 2. So I add 2. Then I'm going to do -3 plus 2. So that gives me -1. I cannot have a magnitude of -1. Okay, so I'm going to loop through my array again. And then find a magnitude that is not -1. So that will be 2. Oh no, so I'm done with 2. So okay, so I'm done with -3. That'll be +2. -2. Yeah. Wait a minute. Wait, okay. Okay. -1 plus -2 is -3. I need to find a magnitude that's not 3. So let's try 1. Okay, so now I have 1. So now we have -3 plus -1 plus -2. -3 plus 1 is -2. Need to find a magnitude not equal to -2, so -1. Then I have 0. Okay, I think I found a pattern. What if you just get every positive, negative, positive, negative? Right, so these values could add up to 0. But as long as the first value doesn't add up to 0, that's fine. So, yeah. So what I'm going to do is I'm going to sort the array. So it's sort of like this. I'm going to get negative 3, 3. So I'm going to pair these up, negative 3, 3, negative 2, 2, negative 1, 1, 0, right? So these are going to add up to all zeros, right? So what I'm going to do is I'm going to actually move, I can move this 3 to the end, and then it should be fine. Negative 5 plus 2 is negative 3 plus negative 1 is negative 4 plus 1, negative 3 plus 0 plus 3. Oh, no, that's not right. Let's see. Negative 5 plus 2 is negative 3 plus 1, negative 1, negative 4 plus 1 is negative 3 plus 0 plus 3. Oh, that's not right. Move 3 to the middle. Right here. Negative 3 plus negative 2 is negative 5 plus 3. Negative 2 plus 2. Oh, that's wrong. Okay, that doesn't work either. How did we do it before? We found a formation possible before, right? Negative 3, negative 2. No, I didn't have a 3 here. What the? Wow. That was because I didn't have a 3 here. I don't think this is possible. What if this number is just not possible for in this case? Negative 3 plus 2, negative 2, 1, 3. Is it the case for all of them, though? What if I just sort them? Negative 1, negative 1, 1, 1. I might just actually just try sorting. What was it? Negative 1, negative 1, 1, 1. Negative 2 plus 1 is negative 1 plus 1. Oh, that's 0. 0, that's not good. How did they fix this? Alternate 2 1s in the beginning. Then negative, positive, negative, positive. Negative 1 plus negative 1 is negative 2. Negative 1 plus negative 2 plus negative 1. Okay, plus 1. You can't do that. Oh, move all the positives in the beginning. 1, 1, 1, negative 1, negative 1. 3 plus negative 1 is negative 2. Plus negative 1 is negative 1. I think that'll work. Okay. Oh, just sort it by decreasing order. Okay, if we sort it by decreasing order, then we're going to go through from beginning. We're going to sum up current sum. And then if current sum is equal to 0, then we are going to print out no, possible equal false. Okay, let's see. Uh, if positive is true, then we're gonna do print out yes. Otherwise, we print out false. I think that'll work. Yeah, okay. I think this would work. I'm actually sure this would work, actually. Yes. No, yes, yes. Yes, no, yes, yes. Yeah. Oh, fuck. I forgot to print out all the values. Okay, so we got that. Yeah, okay. I think this would work. Okay. Let's see. I think I'd spend like 30 minutes on this. 30 or 40 minutes. I don't know. Wrong answer on 2. What is the problem? Okay. Decreasing order. Wrong answer on 2. Something happened. Let's keep thinking. Huh. In what case would this not work? Sorting in decreasing order. In what case would that not work? Let's say I have 2, 1. This would not work. Yeah, that would not work. Would this work though? No, that wouldn't work either. That wouldn't work. Two, 1, -2, -1. No, that wouldn't work either. 3, so 2, no. I don't think this would work. Let's say we had. So we had this. Ah. Ah. Okay. Sort it in increasing order. If it doesn't work, try sorting in decreasing order. If that doesn't work, then it's just not possible. Okay? Because if I sort it increasing order, -1, -1, 1, this would work. So let's try that. So It's not possible. We sort it in increasing order. And try it again. Do the exact same thing here. Try it again. If possible is yes, then we see out yes. Otherwise, okay. I think this would work. Not 100% sure though. Still not working. Okay. Let's think. Increasing order doesn't work. Decreasing order doesn't work. Could there be a false positive? Oh. What the? I didn't print it out. What the? Maybe that's why. And I got AC. That's what I'm talking about. Okay. All right. That took a while. That took a while. How long did it take me? 36 minutes. It doesn't even tell me. 45 minutes. It took me 45 minutes. Okay. Next problem. Nice. Yeah. Thanks. Maybe I should go to Twitch. I don't know. Like, you go on Twitch? I mean, okay, I know Twitch is mostly for video games, but like, do people actually stream on? I don't know. I think there's a way to stream on all platforms like Twitch, YouTube, and all the other stuff. But anyway, let's go to the next one. Okay, chess. You have N games. You take a problem. Each test game is either won or lost. When you lose a game, you get 0. When you win a game, you get 1 or 2. If you have won, also the previous game, you get 2 points. Otherwise, you get 1 point. If you win the very first game of the tournament, you get 1 point. There's not a previous game. The outcome is... You notice a bug on the website allows you to change the outcome at least K of your games. You could change L to W, W to L. Since your goal is to improve your chess rating, you decide to cheat and use the bug. You want to maximize it. Okay. Lose, you get 0. Win, you get 1 or 2. If you win the previous game, you get 2 points. Otherwise, you get 1 point. Greedy? Can we use greedy? We want to maximize it. You can use at least K of your games. Okay, I think I got a greedy algorithm. Let me get my drink of water first because my throat hurts. And then I'm going to try this. Okay, I'm back. Ooh, okay, that was a good drink of water. Woo. Okay. If you won also the previous game, you get 2 points. Okay, so let's say we had LLWWL. Okay. Okay. These are losses. You get 0. You won 1. You get 1. You lost 0. 1 1 1. If you swap this and this, oh, not swap. If you change this L to a W, you get 0 0 1 2 2. So you get 5. I think that would be the maximum points. Unless you could. Okay, so it's better to go through the string first. Set every string that has a W lost W, and set this to become a win, right? At the end, if you still have more values you could change the losses to wins. I think that'll be the greedy algorithm. Yeah, so we could change end games. Lose a game, you get 0. Win, you get 1 or 2. If you won the previous game, you get 2. Otherwise, you get 1. If you win the very first game, you get 1. There's no previous game for the first one. Outcomes represented by the string. You change at most L. Okay, maximize your score by cheating. Okay. Okay. So we read in T, read in N and K. Yeah, N and K. Okay, do we have a string? Yes. Okay, so string. Okay, string, and then we read in S. Okay. What are we doing? Okay. Okay, so let's look at the first case. WLW LL2. K equals 2. K equals to 2. We can only change 2 spots, right? Change this to a W. So then we're going to have 1 plus 2 plus 1. So that's going to give us 4. And let's then our number of ways we could change is now down to 1. Change this to a W. Now we have 1 plus 2 plus 1 plus... No, 1 plus 2 plus 2 plus 2. 7. Answer would be 7. Yeah. Okay, so I think that would work. Let's look at LLLWWL. 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 Okay. What is our K? K is 5. Change 5 moves. Let's make this to a W. So now we have 1 plus 2 plus 1 plus 2 plus 2, so it just gives us 5. Let's make this to a W. So then now this becomes 3. What do we get? 1 plus 2 plus 2 plus 2. 7. right? Let's make this to a W2. Wait, we have way more W's than losses. You can make all these W's. What the heck? I'll just be 2 times. Yeah, okay, so every time we see a WLW, we change the middle to a W. Okay, so that's what we're going to do in the beginning. We need to find. So let's see. Well done. Okay, thanks. So yeah, we'll actually just go through um uh yeah, okay. So if S at I is equal to a W, so if all these are true, then we're going to set S at I plus 1 is going to equal to a W. Okay? Okay, I think that's it. And K minus minus. Okay, so that's going to get you down the first case. Yada 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 yada. Let's find the first occurrences of the W now. So from here, let's find the first occurrence index of W. Find the first occurrence of a W, and then we want to let's see. Yeah, okay. Find the first occurrence of a W. Okay, here's a problem. Let's say we have lost W, right? And then we get this down and we have this to become a W, right? But if my K is greater than number of W's, like K is equal to, I need to get the first W and loop downwards to find the first W and the first L, right? Or I could find the first. No, wait, no, that doesn't make sense. Yeah, okay, I could find the first L. And then while this is not equal to a W, we just keep decrementing K. Okay, we could do that. So and K is greater than 0. I'm gonna find the first L. Then while I'm gonna loop from this L plus 1 up to J is less than N, and the string at the Jth is equal to an L, right? Then we're gonna set S at J is going to equal a W. Okay? Then we do K minus minus. Oh, actually, I could do it this way. Make this into a while loop. The reason why I want to make it to a while loop is that I could change my index. Okay, so once I've finished setting these up, I want to change my I to become J. Right? Because then that's the final value of the W. Okay, actually, do we want to keep doing this? We might not want to do this. We might want to keep going. I think we should keep going. Every time we see a L, I don't know. Okay, let's just see what this does, okay? Yeah, and now at this point, let's just count. Loss is 0, so if it's a win, you need to check if the previous one is a win, then sum plus plus. That's great. Okay. Yeah. Yeah. You also need to check out the first one. If its first one's a win, then we add by 0. 1. Yeah. I think that works. Seven. Oh, this one's wrong. Crab cakes. Okay. Why is this 0? I can make this 1. Oh. Let's get rid of this. Okay. Getting closer. Go closer. 7. This is wrong. Let's see. 7, 11, 6, 26. 7. I got 8. That's not right. Let's see, what is our string here? What is our string for this? 65LLLW. Let's try this. Win. L. Huh. It's alright. Win. L. Make this win. 3. 1, 2, 3, 4. We have greater than the 5 numbers. I don't know why it didn't. Okay, if k is greater than 0, let's check if the first value is equal to L. K minus minus. I said 0 is going to equal to a win. Now it should work a bit better. Okay, so we got 7-Eleven. What is this? Why is it 6? Why is it 26? Whoa, I'm 1 off. 25. Why is this 59? What the hell, man? 0, 1, 7. 0, 1, 7. Chess cheater. What up? Oh, what up? I feel like it's like... Hey, Dragoon. Hey, Dragoon, how you doing? Okay. What if we just did like... I don't know. At most K games. That's like... What am I doing wrong? We have 6. 6. Okay, let's go back. What did I do wrong here? What am I doing wrong? We have two L's, 2 W's. 7, 11, 10? 10, 11? Wait. Let's see. 10, 11, 12. So we have 10. So we have 7, 11. Why did I get 10? It should be 6. How did I get... did I double count? Let's see. How did I get 10? Wait, that's actually really weird. How did I get 10? But like... How did I get 10? Wait. Let's see. 6, 5. So we have 7, 11, 6. 7, 11, 6. Okay, so this is the test case. 7, 1. LLWG del. What did I get? How is this a 10? Wait. Whoops, my bad. So we have LW. Okay, so we have LWWWWWL. How do you get? Okay, so let's add them up. Okay, this one's 1 plus this is 2 plus 2 plus 2 plus 2. So this is 7. Wait, that actually doesn't make any sense. 1, 2, 3. LLW1. Wait, we only could change 1. Hold up. How did the string change 4 times? That's a big question. How did the string change 4 times? Oh boy. Crab cakes. Oh. Whoops. Remember, we only could change the occurrence. We only could do one operation once. So this only continues when it's greater than 0. Okay, so this should avoid double counting, and I think this should work. Should work now. I don't know what I'm doing. Let's see. 7, 11, 8. Okay, now I double count it again. I double count it twice. 7, 11, 8. 25. Miscounting 1. Triple counting for some reason. Miscounting 1 again. Okay. So which one am I miscounting? What am I counting incorrectly? So ridiculous. I think this would work. This would work. This should work. So if we had... okay, I'm still double counting way too much. So 7, 11, 8. 7, 11, 8. I should be 6. What am I double counting? So 1, 7, 1, LLW4. Let's see. Something is not right. Ideally this algorithm... Okay, this algorithm should work because it would find the first one and then it would set the W and it would end. So something is wrong with the way we coded this. Whoops. Sorry. So, okay. So once we did this, 7, 1. Whoa. So, okay. So we have 7, 1. Then we have to do, LL this. What are we doing wrong? Okay. So if we do 7, 1. Okay. It's going to set it to a W. K minus minus. K is greater than 0. K is equal to 0. K is equal to 0, so it's not. You cannot do this either. Okay. Okay. So is the first one W? No. Right. So this is right. WWWLWL. So it should give you 1 plus 2 plus 2, which is 5 plus 1, which is 6. So 1, 2, 3, 5, 1. Why did it keep going? Oh, crap. Dang. Okay. Stupid if statement. Okay, if I take this out, I do this. This is what I want. Okay. Now it should work. It should work now. Okay. I was just like triple counting. Work. No. Something's not right. Oh, wait. Okay. 6, 7, 6. What? Okay, now I'm losing my mind. Okay, so we're screwing up with the first one. We have 6, 11, 6. So 6 is right now. Losing count. This is right. 46 is right. 0, 1. We're miscounting the last one. Okay. Okay. Excuse me. Excuse me. Excuse me. But if we do like W, I'm trying to think. What if we do like W? Because if we, okay, what is going on? What is the problem? Why am I not counting something and all of a sudden counting everything? Like, that doesn't make any sense. Okay, 1. That's 5, 2. Okay, 1, 5, 2, and then what was it? WWL, WWLL. Okay, let's do this. Okay, initially WLWLL. Okay, let's try this again. Let's do this on paper. WLW. Wait, well, I forgot it. WLWLL. Okay. Okay, so if we do like WLWLL, WLWLL. Okay. How many operations can we change? We could change 2. Okay, I'm first going to change this to a W. So this is going to be equal to 1. Then I'm going to... Oh. I'm going to go to the last W, and from here on to the end, I'm going to change this to a W. Okay? Yeah. So then this would be down to 0. So then this would give me 1 plus 2 plus 2 plus 2. And that'll give me 7. Yeah, I think that would work. That'll work. That'll work. I don't know. I feel like... I have no idea. Am I even live? Oh, no, I am live. Wait. Yeah, wait. Yeah, I am. Wait, what the heck? Okay, something... I think something's... The problem is that I'm checking... So, okay, let's look at the code again. So here I'm checking... Oh, here I find the first L, and then I go down while it's... Oh, but that's right. I go up. In this case, I find the first L, and then I go up. So this actually doesn't make much sense. Okay, hold up. Let's see. Yep. We're out of 1. So we're going to find the first L. Oh. Oh, crap. Okay, yeah, this should be that. Should be I. Okay, find the first L, go to the end. While it's equal to an L, we're going to decide equal to W. Okay, that works. That works. That works. Okay, yeah, I think this would work now. I think this would actually work. Let's see if this works. Okay, 7, so 6, so 7, 11, 6, 26, 46. Okay, I'm missing one. Whatever. 46, 0, 1, 6. 46, 0, 1, 5. Okay. I'm off by one for two cases. And I think I should be able to figure out the last case. Okay, so we have W, L, L, W, L. Should be a 6. Wait a minute, 1, 6, 1. This should be a. Why is it 5? I'm not counting something. 1, 6, 1. This. Let's copy this. Why is it 5? That's a big question. Why is it 5? Okay. So if I do like 1, 6, 1. It didn't set any of them to an L? Oh, -2. What the? Wait a minute. Wait a minute. Yeah, okay, that's right. Okay, let's see if this works. Let's see if this works. So we have 7, 11, 6, 26, 45. 45, 0, 1, 6. Okay, 45, we're doing it wrong. Why are we doing it wrong? Okay. Let's actually write this out and see why we're doing 45 wrong. Oh, boy, this is going to be one long one. LLW, LW, LW, LLW, LW, LW, LLW, LW, LW. 2 W's? Wait. LLW, LW, 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 2 W's, 2 W's, LW, LW, so LW, LL, LW, LL, LW, LL. Let's see, what was it? LW, LL, WLW, WLW. Really? WLW, WLW, W. WLW. WWW. LW. LL. LWLL. Hold up. Okay, this something doesn't really make much sense. LWLL. LWLL. Then we do WLL. W. W. L. L. W. L. L. W. L. 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 Okay, I'm not doing this on hand and paper. Let's just try to do debug based on the actual code, because this writing it out is a pain in the butt, actually. Maybe I could copy and paste it. I don't know. There's like 40 characters. It's a pain in the butt. Such a pain in the butt. Let's see. Okay, okay, why is it 45? Something doesn't make any sense. How am I off by 1? Okay, Jeez Louise. Okay, make all these WL. Okay. Tell me what the actual string looks like, please. Afterwards, give me something. It's gonna go. Is it done yet? Done yet? Oh, okay, okay, it's done. Okay. LW. Okay, it might be better if we print out the string instead of just going through the console log. Yeah, let's print this string out. Yeah, let's try it. I mean, we try our best. Okay, so we did make these W's, W, W, any other W? No, okay. Then what is the string afterwards? After K operations. Okay, so what does this give us? You want to bring. So how much is our K? K is 0 now. What did we remove? After K operations, let's see, before K. Before K is that. So what did we change to a W? Okay, we changed the first one to a W. But then that's not right. We shouldn't just change the first one to a W. We want to find the last occurrences of a W and keep going. Oh boy, this sucks. This sucks. Okay, how much time? How many? Oh, I've been recording 132 minutes. 1 hour and 32 minutes. Huh. It's something. That is something. But, I don't know. Just keep trying. We are going to get there somewhere. We're going to get somewhere soon. Okay? At most K operations. What if we... Let's think. What if we did like, find the last occurrences of a W. Okay, so we don't want to start with the beginning. We want to start... Let's loop through it again. If something is a W, we want to find Oh, okay. Um, okay, I got it. Okay, so we don't want to do this. We don't want to do this. This is not a good idea. This is fine. This is fine. You don't want to do this. What you want to do is you want to find the first character that is an L, but the last character, the one previous to it, must be a W. So the one previous to it is a W. And the reason why you want to do this is because what's wrong with this? Oh, my bad. The reason why you want to do it this way is because from our log statement, let's say we had like LLW, LLW, WWL. Okay, and we have K is equal to 1. Do you want this? Do you really want to set the K? Actually, let's say this is an L. Do you really want to change this to a W? Because that's not what you want. You want to change either the first occurrence of a W down to an L, and then change those, or you want to change the last occurrence of a L, like last occurrence of a W, and then from here on to the L, right? So if we had like, yeah, so one way you could do this is loop through it, find a W, find an L, and the last one, the one before is a W, and then from here on you loop to the end, and you set those as the values. Yeah, so the last one, the one before is a W, and then here you're going to loop to the end, and while it's an L, we are going to set it to a W. Okay? Okay, yeah. I think this would change it. This should change it. You gotta be kidding me. Okay, so we have 7. Oh, damn. Oh boy. 7, 6. Okay, so this is not right. Okay, so this is not right. So we have to do the same thing going the other way also. So, yeah, so here we set here to go down, but we also need to find the first occurrence of a W and then go down. So first occurrences of a W. So we have to iterate backwards. So let's do this, copy this and paste it here. Greater than 0. I minus minus. How do we do this? This is difficult. This is difficult. So difficult. It's so difficult. I mean, it's like, I don't know. No can do, boy. Start from the end. You need to find the one where it's a W, and then the one before it is a L, and then we did loop downwards. Okay, so we have to find the one where it's a W. The one before it is an L. Then we're going to start from I minus 1 and loop down. J minus minus. Make it into a W. Wow. I think this would work. Yeah, this will work. This work? Would this work? I don't know. I don't know, man. I don't know anymore. I don't know anymore. 7, 11, 6, 26, 46. Is that right? Yes, 46. 0, 1, 6. Yes. It works. It works. It works. Oh my god. Oh my god, this is amazing. This is amazing. It actually works. Let's try it again. Let's try again. Let's try again. Oh my god. 0, 1, 6, 46, 26, 6, 11, 7. Yes. So I think this works now. Let's submit it. What the hell? Why was I kicked out? Alright, so I got kicked out. Hold up. Let me just really quickly type up my password. For some reason, I got kicked out. Hold up. I got kicked out. Bruh. Okay, time to real quickly change login. Okay. For some reason that didn't work. For some reason I got kicked out. But it is what it is. What it is. What it is. What it is. Okay, let's see if we could submit this. Wrong answer on 2. What is the problem? Ah, I get it. Okay. Okay, let's say we have okay. Would you want to set, where would you put your K? Right? Because my code, what it's going to do is it's actually going to put the K at, so there's no first case where it's a WLW. It's going to find the second case of an L and a W. So like, originally there's an L and there's a W minus 1. There's none of that, so it doesn't do that either. What about the case where it's a W and then there's an L before it? A W and the L before it. So like a W, L before it. Yeah, it'll put the K over here. So make it that a W. But do you actually want that to happen? Let's say we had K is equal to 3. Right? If our K is equal to 3, where are you going to put it? Right? If our K is equal to 3, what will my code do? It'll make this to a W, and make this into a W, and then we have 1, 2, 3, 4, 5, 6. Our K is going to become a 2 at this point. Oh, it become 1, right? But will it make this into a W? That's a big question. So let's try that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9k is equal to 3. And then let's try this test case. 1, 9k is equal to 3. Well, that was a weird reason why I put a space. Let's see this. LW, LWW, LWW, LL. 13. Why is it 13? Let's actually print out the string. Why are you so insecure? I don't know. So what if we tried doing like a WLLWWWLLL? WWWW. Okay, so that works. The problem is that what if what you're setting here, you end up using it, and it's actually not the most optimal value. Right? Like if you have a W and an L, like so I set L and W and I do that first. What if we do... What if it was 1? What would it do first? Right? What if it was 1? Okay, let's try it again. God damn it. WLLWWWLLL. Now, what if this was a 1 though? What if this was a 1? If it was a 1, then we would have like a different... I don't know. I feel like it would be different. It's like if it was a 1, 193 WLL WWWLL. Damn. 193 WW. Okay. I think you need to find the maximum number of L's between a W. Because what if you had like WWWLLL, WLL? 1, 2, 3, 4, 5, 6, 7, 8, 9. WWWLLL, WLL, WW. Like that. Okay? I'll just comment this out for a second. Okay. Yeah. What would this give you? It'll give you 8. I'll tell you to put it over here. But. What if it was a LW? What if this was the number? That would be not right. Yeah, that's not right. WLLWWWLLL. It should put W. On the afterwards. So it should have put a W on the last L. So if we had W. WLL W. WWW LLL. All right, we make this into a W. the proper way is to make this into a W. So then you would have 1 plus 2, 1 plus 1 plus 2 plus 2 plus 2. So then you would have 3 plus 6. We have 2 plus 4, 4 plus 6. You would, wait, no. You would get 4 plus 3. Wait, hold up. Yeah, wait. You would get 1 plus 1 plus 2 plus 2 plus 2. 4 plus 3, which usually give you 7 plus 1 will give you 8. Right? Why would this give you a W? And the problem is that what if you get to 3 or 2? How would you know if the first one... Okay, so like let's say we get... 9, 2. And they said it's 11. Because that is right. But how do you know? Oh. You don't know if it's the optimal value unless you loop through it. Oh my gosh. Oh my gosh. Let me think. This hurts my brain. My brain's hurting right now. Absolutely hurting. Damn, I thought you solved it. Yeah, I also thought I solved it. I did not solve it. I don't know. Let's see. Let's see. How can we do this? Oh, I did not solve it. Oh my gosh. How? Okay. Let's see the standings. How many people actually solve AB? Okay, so we have 6,000. Well, I'm going to say the 6,000th place is better than nothing. How many people are on the 4,000th place? Do these guys actually, do they increase their rank? Oh, no. Oh. Well, let's see their global round. I want to see his global round. Oh, he improved his global round. Wait. Yeah, he did well on his global round. So if you solve the second problem, you should be able to get to green, I think. Let's see. Let's see other greens. Let's see the global round. Okay, so if you were to solve the first two, you would probably get to green, I think. Okay, so if I were to solve this B, which I think I definitely can, I would be able to get to green. Okay, but, I mean, this is not a real contest, so. Okay, the biggest question is that if we have an L and L, how are we going to get, how do we know if it's the optimal? Right? Because let's say I had like, okay, let's just back it up a bit. Let's say, okay, let's say I had like that, right? And then our k is equal to 3. No, k 2, right? Is my algorithm gonna put these into w's, or is it gonna put these into w's? Because the most optimal is probably these, right? You need to find the ones with the most number of L's, actually. Oh. Okay, well, let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's try it. All right, so we have 3 L's, W, L, L. When do we have like 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we have a bunch of L's afterwards. 1, 2, 3, 4. 4 L's. Okay, and this is like 12, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have like 12 of these. And then we have 12 and 3. Okay, that's not what I want. Okay, maybe 12 and 2. I meant 12 and 2. 12 and 2. Ah, that's wrong. Ah, that's wrong. That's wrong. It should have done it on the last two. Because if it done on the last two, you would have... Look, okay, if we had... So if it was like this, it's going to do 1 plus 2 plus 2. Then it'll do plus 1 plus 2 plus 1 plus 2 plus 2 plus 2. 1 plus 2 plus 2 plus 2. 1 plus 2 plus 2 plus 2. Yeah, so that's 1 plus 2 plus 2 plus 2. This is going to give you 5, 6. This is going to give you 12, right? But I don't think that's right. Let's see. I think the optimal solution is... Most optimal is here. And the reason why is because here we have 1 plus, and then let's see, 2 times 1, 2, 3, 4, 5. Oh no, this gives you 12 also. Something's not right. Oh, that's because the L's are not large enough. What if it was like 3? 3 or 4? Let's say it was 4. 1, 2, 3, 4. Best optimal solution is actually put these at the end. Or actually to put 3 in the beginning and then 1 in the middle. Wait, let's see. 1, 2, 3, 4, 5, 6, 7, 8. 4 in the end. So that's 1 plus 2 times... Trying to think. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Three. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7, 8, 9. Just gives you 17. 1, 2, 3, 4, 5, 6, 7, 8. Nah. I don't know. If we find a W, we're going to keep, and one is L, we're going to keep going to the right. See if we encounter a W. If the last value minus the beginning plus 1 and the length of that is equal to K, less than or equal to K. If it's greater than or equal to K, if K is greater than or equal to that, then we set those values to be W's. I don't know. Tricky problem. You can only use at most K of their games. You can only use at most K. Every time you see a W, you should want to concatenate anything between a W. 1, 2, 3. 1, 2, 3, 2. Find the smallest one to add first. Maybe it's better if you add the smallest one first. Okay. Okay, I'll try something that is uncalled for, but I think it'll work. Okay. So what I'm going to do is I'm going to find the smallest number of L's that are between a W. So if we have this W and this W, this is going to be 3 L's, right? Now what we're going to do is that we are going to actually, if this number 3 is less than the number L, a number of K, then we, yeah. Actually, I don't know. I'm trying to think. L, 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 L. Two plus 2. You put a W here. You add by 1. That doesn't make any sense. If the last one is a W, you should be able to make it a W. But it doesn't make any sense to me. Should you sort by number of L's? I don't know, actually. Oh no. How long has it been Another hour. Huh. All right. Let's think. Let's keep thinking, and then if I still can't figure it out in like another 30 minutes, maybe I'll just look at the solution. But I really think this is definitely not that difficult. Like, I really think you could definitely figure this out. Definitely fill those values of k first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, well, well. If it isn't the fire ferrets. Well, 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 well. Why isn't this working? Because if you tried 2 L's and 2 W's, that's not going to help you get much where. But if you put all 3 here. Let's say it was this. W L L L W W W W L L 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's say it was 10, but it's a W L L. Okay, 10. We're gonna use 2 W L L L W W W W L L 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There he does the first 2, and that's not right. He would have made a better progress if he had done 2 on the left instead of first 2. Right? Hold up. Well, let's see. Let's read it. Let's look at this. Let's say we had L W W W W W W W L L. Okay, like that. What I did was I set these 2 as W's. Then what this happened was 1 plus 2 plus 2. Plus 1 plus 2 plus 2 plus 2. Which this gets you 2 plus 1, 2, 3, 4, 5. 2 times 5, which gives you 12. Okay, let's rewind and think, what if we didn't have 12? Isn't it better to put these as W's? Right? Then you would have 1, 2, 3, 4, 5, 6. 1 plus 2 times 5. Oh, wait. No. 1 times 1, 2, 3, 4, 5, 6. Oh, wait, no. Yeah. We have W 1 plus 1, 2, 3, 4, 5, 6. Huh. Yeah, you would actually get the same number as 12. 2 times 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. 2 times 5. Oh, that's strange. But if it was 3, what would my code do? If it were 3, what would my code do? W L L L W, 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 W. It'll make them all the 3s. W3, what if we had like W, wait a minute. W, L, 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 W, 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 L, L. Right? What if we had this? 2, 1. My code does it right. What if the WLLL is on the back? Right? What if the WLL is on the back? How are you going to do that? At this point, how are you going to do that? WLLLL. WLLLL. It set the first 2 to become W. What if there was 3 W, 3 L's? I'm still trying to figure this. Okay. Okay. What if there's an WL? L. What if there's WLL? Okay, I got it. I got a good one. I got a good test case. Good test case. What if it was 1 WL, WLLL, WWWWLL, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, is it 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 10, 11. Okay, it's 12. What did he change? He changed just the first W. But then he also changed it to L's. But that's not right. Oh, no, that is right. This is crazy. This is the most craziest thing I have ever thought of. Well, oh my God. This is the most craziest thing. My God, this is really difficult. Pug G, what is that? Pug U? I'm still trying to figure this out. I am so ridiculously trying so hard. I'm trying to figure out the test cases that would probably cause us to fail. But I don't really know. Like, I'm not 100% sure what would cause us to fail. Because my code seems like it's giving something right, but I don't think it's perfected, like... Okay, what if we done this? These 2 L's become it 4 instead of that. I think I got one. Okay. I got one. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright. Alright. I think I got you. I completely got you. I have defeated you, code. Fuck. Damn it. It did it right. It did it right. Ah, what if I move the first two L's to the end? What if I do that? Huh? Would the code give me the right number? WWLLW. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 4. WLL. Oh, we have WWLL. WWLL. LLL. Fungi. It did it right. It did it right. It did the right thing. It did the right thing. That's because it looks at the first L. But that might not be true. The first L may not always be right. I got it. I got one. Okay. What if we had L W? What is it going to do? Huh? 1, 2, 3, 4, 5, 6, 7. And then I do 3. What is it going to do? 7, 3. L, 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 W. 1, 2, 3. Crab cakes. It did it right. Keeps doing it right. Something's not right though. What if I had a W, an LW, or WL? What is the problem with my code? I don't even know what's the problem at this point. This is so difficult now. Like, I don't know. I don't understand. Don't we just want the longest W possible? Isn't that what we want? Longest contiguous W's? Longest W's? Longest contiguous W's. What if we had like one L. Okay, 3 L's. Let's say we have 3 L's, right? Now let's say we do like, I don't know, 2. And we change these 2 to become a W. Then what do we do after that? What do we do after that? Because here's a problem. The moment you change these 2's to become W's, I don't know if the code actually makes these 2 become WL. Maybe it's because of WL. I don't know. I don't know. It might be better to find the most common W. Maybe. I'm not sure. I don't know. Okay, I'm going to give up. I'm going to try to solve this problem on my own. Rate, comment, subscribe, guys. This live stream has gone way too long. Way too long. 2 hours, 21 minutes. Hope you guys enjoy this live stream. I'll check you guys later. Peace.